Lesson 7.3 just covers special products of polynomials, and in this case, there's 3 different formulas that can be applied to any binomials that fit the definition of a plus b squared, a minus b squared, or a plus b times a minus b. So you don't have to know these necessarily, but they can be really helpful for calculating products of polynomials without actually having to do the FOIL method or the distribution method. So this lesson will focus just on these special products, and if you memorize them, it may save you a lot of time down the road. If not, it's not actually going to be a big problem, but you will have to multiply everything out longhand like we did in the last lesson. So let's just go ahead and start with this first formula over here. A plus b squared equals a squared plus 2ab plus b squared. So basically what that's saying is if you have something that looks like this, 3x plus 5 squared, what you can actually do is identify 3x as a, 5 as b, and you can take this formula here and fill it in with the correct values to find the product without actually having to multiply. So what I'm going to do is I can rewrite the formula here, and then I can just fill it in with my values. If I know that a is 3x, then I can fill in everything that says a with 3x, b is 5, and from there I can simplify and find my product without multiplying anything at all. So 3x squared becomes 9x squared, plus 2 times 3 times 5, which is 30x, plus 5 squared, which is 25. So that's just a faster way of finding the product of this special polynomial. So if I had done it the other way, 3x plus 5 times 3x plus 5 like this, and if I had done the thing where I distribute everything, I will get the same thing, it will just take me slightly longer. Either way of finding the answer is valid, but this lesson, like I said, is just going to focus on these special formulas. So now we're going to focus on this formula here. A minus b squared is equal to a squared minus 2ab plus b squared. So we'll do an example of that. So in this problem, we see that I have 2x squared minus 1 all squared. So what I can do again is I notice that because it's a perfect square, I can identify this as a. So from here, I can just recopy my formula, this one here, and get a squared minus 2ab, and I can just start filling in those values. So a is 2x squared, b is 1, and from here when I square 2x squared, remember that this exponent out here applies to both of these terms on the inside. So what I'll get is 4x to the 4th minus 2 times 1, which is just 4, so minus 4x squared plus 1. So I didn't actually have to multiply anything out. So let's just go ahead and do it the other way so we can see how that plays out if you multiply it the long way. So again, you can see that either way I'm going to get the same thing. Alright, let's work with this last formula, a plus b times a minus b, which has this result here, a squared minus b squared. So in this case, again, we're going to split it up and say that 3x is a and 2 is b. So from here, we can just fill in our formula, a squared minus b squared. So instead of writing a, I'll put 3x, and instead of b, I write 2. So I'll get 9x squared minus 4. So let's say I wanted to do it the long way. If I wanted to multiply this out, I'd have to distribute again, and I would get 9x squared minus 6x plus 6x. So you can see here that this term and this term will cancel each other out, and that's why it goes away and it's not in this final result over here, all minus 4. So yeah, these are just some shortcuts that you can use in the future.